We just finished the last video talking about this graph and how we have an increasing graph whenever my base is greater than 1. So let's now graph example 5, which is y equals 2 to the negative x. Now these are almost the same. The only difference is that negative x. Whenever we have exponentials to be in the correct form, we want this exponent portion to be positive. So I'm going to rewrite this as y equals 1/2 to the x power. That was one of our exponential rules again. So we took that, put it down to the denominator, and now it's to the positive x power. Okay, so let's go ahead and graph this. And it does not matter how you want to graph this. You can do x or 2 to the negative x power, or you can type it in as 1/2 to the x power. It does not matter. I'm going to go zoom 6. And here is my graph. So I can see by just looking at the graph that this one should be decreasing. And let's find our values. So I'm going to go over here to table. So go second graph. And the first y value that I can put on my graph is -3, 8. And let's go to 2. Okay, so pause this video so you can plot these all. But before we connect these, let's talk about what's happening. Because my base is now 1/2, that's why everything is getting cut in half. 1/2 times 8 is 4, times 1/2 is 2, times 1/2, times 1/2, times 1/2. So we're going to keep halving. We're going to get closer and closer to 0, but we will never touch it. So we have another horizontal asymptote right here at y equals 0. And I again have that looking like it's under the x-axis, but that's more so it will just show up. But we have the same horizontal asymptote at y equals 0. So when I connect these points, we're again not going to go over that x-axis. Okay, now that we have that graphed, we can answer the rest of these questions. The domain, we go from left to right. Goes arrow, negative infinity to arrow, positive infinity. And again, exponentials have a domain of all real numbers. The range, as we go from the bottom to the top, the first thing that we go to is that horizontal asymptotes. We have 0 with parentheses, and then it's going to keep going up forever, so to infinity. This, we have no x-intercepts because we have a horizontal asymptote on the x-axis, but then my y-intercept is again at 0, 1. So as you can see, these are almost identical, like in these boxes. The only thing that's different is one's increasing and one's decreasing. Now let's explore what happens when I have different bases here. So we just graphed this one here, 2 to the negative x. Now, if I have 1/3 to the x, which is the same as 3 to the negative x, now everything, instead of getting cut in half, is going to be divided by 3. So this is going to decrease a lot quicker because everything is getting cut into thirds. Now you have cut into 4, so it's going to decrease even faster, even faster, even faster, even faster. They have the same two things in common here. They have a y-intercept at 0, 1, and they have that same horizontal asymptote. And again, this cannot equal 1. And what I mean by this, the base cannot equal 1 because 1 to any power is 1. Now you can flatten this out here by getting closer and closer to 1. But you cannot, once you go over 1, then you have an increasing slope or an increasing function. So here we are always decreasing when our base is between 0 and 1. So when that base is between 0 and 1, decreasing, anything above 1 will be increasing. So let's go to the next video and we will start transforming these graphs, and we're going to be shifting these up, down, left, and right.